the table. All right? So now what we're going to do is, has that been hard so far? Yes. All right. So let's breathe, because it's going to get much harder. Oh, you know it was coming. You know it was coming. All right, so now what we have is we have an NFA, and we need to convert it into a regular expression, right? And it's going, maybe it's not harder, but it blows up really fast, really scary, all right? Maybe it's harder. I'm going to go with harder. All right, so again, we're going to make an iterative algorithm with the loop invariant, right? We want to go from an NFA to a regular expression, but we can't do it all in one step. So we're going to have intermediate steps, all right? And we're going to want to be smooth transition from the regular extended regular expression from the NFA to the regular expression. We want to have a smooth, slow transition. All right? So we need to jump into the middle of the computation and see what our loop invariant is going to be. And what is it going to be? We're going to build some weird thing in between. What the heck is that? Exactly. It's kind of a mess, isn't it? And so what it is, we're calling it a generalized NFA. And it's just like an NFA, as in it has states and edges between them, and a start state and an accept state. But we're not going to label, the edges could be labeled with single characters. For an NFA, the edges were labeled by single characters. But now the edges are labeled by extended regular expressions. Right? Everybody kind of buy that? And all right, so what does an NFA do? Right? We say an NFA accepts a string if there exists a path through the NFA labeled by the string from the start state to the accept state. Right? So now we have this crazier thing. Right? This crazier thing is going to accept a string if that string is concatenated by a number of substrings such that following a path from the start state to the accept state, each edge is labeled with a extended regular expression that accepts the substring in question.
We'll be going through later on.
Examples?
No, like that, like slowly, like that arrow one by one.
Yes, we're going to build things like this. This is what we're going to do. You're not supposed to understand that. I don't understand that. It's just kind of a mess of arrows and it's just a picture to show you what these things can look like.
Was it meant to scare us?
Sure. Halloween's coming. Everybody can dress up as a generalized NFA for Halloween and terrify the neighborhood. Yes.
So it's just pretty much an NFA, except you have, for the edges, instead of one character, you have a bunch.
You have an extended regular expression.
And you're saying that a string has to have pretty much those edges, a combination of them at least.
Yes.
We say extended regular exception even if we only have like the union, which belongs to regular expression. But we don't have anything that belongs to extended regular expression.
It's just an example. All right. So here is a little bit of an NFA, right? And we want to say, what can we accept when we go from Qi to Qj? And what we're going to in fact do is we're going to be taking the states and we're going to ripping them out. So anyway, this is sort of an example. sorry, this thing accepts, we're just doing examples here, right? It accepts going from qi to qj, it accepts 0x, right? Because there's a path labeled 0x, right? And now this one accepts 0AAAX, right? It accepts 0A star x, right? You go 0 A star x. That's what this thing accepts, right? And that's what our goal is to convert NFAs into regular. Oh, I guess we're going the other way, aren't we? We're expressing these ones into. No, we're going NFAs into regular extended regular expressions. So that's exactly what we're doing. Not extended regular expressions. NFAs into regular expressions. All right. So now, what's this one accept? Well, it accepts things of that form, right? It accepts this thing concatenated by this thing, right? Follow that, followed by that. Yes?
Is that QK like used to concatenate?
Yeah, kind of it is.
So you need something in between.
Yeah.
A node in between the two nodes of.
Well, instead of doing this, we're going to do a concatenation to get from here to here. Right? Well, right now, this is the start and this is accept. But really, this is a little piece of a big picture. But we're saying, to get from here to here, what do we got? You got this and you got this.
Yeah, but in your regular expression, the empty string is also a part of it, except the one.
No, because you got this one here.
But you get QK.
All right, so what about this? What does it accept? Right, what strings does it accept? It accepts this concatenated with this starred concatenated with this. Right? Everybody kind of see how we're working on converting NFAs to regular expressions. Yes?
Very first one, which was 0 A star x. How come those were concatenated straight?
Well, if this wasn't there, you have to do this, right? But since this is there, you can do this and as many of these as you want, maybe 0, and followed by one of these things.
I can't make another node with an A star.
Our whole goal is to get rid of the NFA and build the regular expression. Yes?
Isn't it the same thing if you put little dots in concatenation versus just sticking them together?
No, yes, it means the same thing. So the reason I put it dot here is I wanted to emphasize that I'm concatenating these pieces, while I wanted to de-emphasize that this was I was thinking about this as a unit. Any more questions about this? So now, our goal is going to be to rip out this node here, right? To remove the node, yes? Yes, right? Now we're going to have, you can do this star, this, or union, you could do this, right? So you could do this guy here, or union, you can do that, this star, that. Right? People following this? Maybe this isn't so bad. You guys, the guys who normally respond are responding positively, and the guys who don't say anything aren't saying anything. So we're doing fine. Yes.
Is union symmetric?
Union is symmetric. Yes. You knew that. Yes?
So, I mean, this is just an NFA all over again, except just longer stuff on the edges. Companies, right?
Yes.
So what's the hard part here?
If you're good, I'm good if you're good. Right? All right, so So what we're going to say is we're going to start with an NFA like this. We're going to start with an NFA. And what we're going to do as we move along is we're going to have a generalized NFA that does the same thing. All right? So all we have to do is say, how do we establish the loop invariant? How do we maintain the loop invariant? Right? Well, and how do we get the post-condition from the loop invariant in the exit condition? Right? So we can get our post-condition. So the first thing we're going to do, I don't know why that little guy jumps, but it does. Oop, jumps. All right, how do we establish the loop invariant? Well, if we start with an NFA, it is a generalized NFA, right, already, so we don't have to do anything. But just to make our lives a little bit more complicated, we're going to, if it has more than one more than one accept state, we're going to have epsilon transitions to a single accept state. So it has a single, we want our guy to have a generalized guy to have a single accept state. Right? Everybody follow that? So when we start with our NFA, it already by definition is a generalized NFA, right? But we're going to change it a little bit. If it has more than one start state, we really want one start state. So we we have epsilon transitions to a single start state, to single accept state, right?
We're doing the same with start.
And I think we're doing same with the start state, right? This start state may have a lot of things looping and looping around it, and we don't like that. So we're going to have a new start state that has an epsilon transition to. So now we have a nice clean handles of the start and the end with messes in the middle. And so we know it's really clear where we're starting and where we're stopping. All right? So that's how we're going to start building our generalized guy. Right? And then how do we end in the end? So what we're going to do is we're going to have this thing, we're going to keep ripping out states. We're going to rip out states until there's no states except our new start state and our new accept state. Right? Right? We're going to start with our NFA. We're going to add a new start state, a new accept state, and then we're going to keep ripping out states in the middle. And we're going to keep ripping them out, and we're maintaining the loop invariant that what we have accepts the same language. Well, we're going to maintain that. As we rip them out, we're going to maintain that it accepts the same language. And then eventually, it's going to be, all the nodes are going to be gone except our new start state and our new accept state. And there's going to be one big regular expression in the middle. Right? And that one big regular expression has to be the same language as this. And so that will be our answer. Right? Does that make sense?
Yes.
Yes! Excellent!
Not the language of that expression, no, right? It's a different language, right?
No,
That's
all
the
of
string.
this regular expression has to be the same language as what we started on.
When you rip the nodes out, you're drawing the regular expression.
Yes. Yeah, I haven't told you how to do that yet, so you can wait on that. We ready to rip a node out? Now, let me tell you a little bit. I always try to tell people everything I know about the exam that's not giving it away. So in the past, when I had to put this on exams, can you imagine, we'll see an example. You can imagine if you start with a regular expression, we start with an NFA, and if you have to do the entire process, it will take pages and pages of nonsense, right? So I've never actually made anybody do that. But I have plenty of times said, or here's a generalized NFA, give me a new generalized NFA where you rip out a particular state, and I tell you which state to rip out. Right? So you're doing one step in the process as opposed to the whole thing. All right? Does that make sense?
Good soul.
I'm a good soul. Thank you. All right. Right? Each step we rip out one. Our measure of progress is the number of states in this generalized thing, and each step we rip out one state. All right? So let's do it. There's our. All right. So imagine there's a big generalized NFA here, right? And I'm just showing you the parts of it, little parts of it at a time, right? I'm starting by showing you the node that needs to be ripped out. All right? So we have this big generalized thing here and this node, and what we have to have in the end is the same generalized with this node gone. All right? So we basically have to look at every way that this ripped out state affects things. Every way you can get to it, every way you can leave from it. Right? So for every pair of nodes, Qi and Qj, we're going to think, what is the effect of taking this guy out? Right? So we're going to be ripping that guy out, and we're going to have a new edge that, and we're going to replace it with an edge coming down here. Right? And so maybe there was already some regular expression that allowed you to get from I to J. And there was some regular expression that let you get from I to rip. And there was some loop that allowed you to get from rip to rip. And some regular expression that allowed you to get from rip to J. Right? And when you rip this guy out, we have to make all those pieces still work. Right? So what are we going to write here to replace it? Anybody want to guess? Right, there it is. How do we get from here to here? Well, we could have done this, or we could have done this, followed dot, dot, followed by as many of these as you wanted. That's a star, followed by this. Yes?
When this one's done, do we assume that you're multiplying? Yeah, it's multiplying, right?
You mean why didn't I have a dot in here?
No, I was asking, like, if it's the same.
It is the dot. She asked it just a minute ago. Dot and no dot's the same. I just didn't put it there because I didn't.
Got it.
Everybody good? It's like multiplying. You can put A and B together. It's not multiplying, but in fact, in some ways it is.
It is.
All right, everybody good? So we maintain the loop invariant that these two things are equivalent, right? Everybody can see how they're equivalent?
You put it or not.
So, of course, I said you have to do every I and J. So if you do this I and J, you have to do this I and J, this J and I, right? How do you get from J to I? Well, you do the Ji thing, and then you do, what are we doing here? We're going from J to I. You go J to I, or you could go from J to rip, starred, or from rip to and then rip to I. Everybody kind of buy that? And the only thing that's a typo is this here should be backwards.
So you have to show the opposite side as well?
Yeah, you have to do all IJ pairs. Well, you have to, for every edge of the new guy, you have to think about it. For every edge of the new guy, you have to think, how did I get my rip? You got to deal with the fact that you've removed the rip.
But that's only when you're going both ways. If you're going one way, you only need to
Yeah, but the computation might go both ways.
Like, how about that? That at the top left. That would be one way, right? The very tiny one at the top left,
Very what?
next to the fairy godmother. Yeah, that's it. That's only one way.
Yeah, but that's just an example. That's just.
For that one, you wouldn't need to show the opposite.
Yeah, if something wasn't here, then you don't. Then it becomes easier. Everybody follow that? And of course, you have to do it for every possible, right? So you have to do from I to K, and from J to K, and from K to I. You got to do all the edges.
Even K to J.
K to K. Oh, you have to do, right? So you do I to K. And here's another fun one. The self loop from I to I. Right? Yeah, how do you get from I to I? Well, you can either do I to I, what you did before, or you go I to rip, rip star, rip to I. Right? You have to do it for every pair IJ. Everybody get that? So you can imagine, even this one step, you're adding lots of chaos to this poor guy.
So in the exams, you're going to be specifying what exactly we need to do. Like the questions are going to be like, you're going to be ripping out this note, and you're going to be writing your answer like this, something like that.
I can't give you the exact exam question. I haven't made up the exam yet. That's what I've done in the past. But who knows? I might do something really crazy this time. All right?
You got a minute left.
We got a minute left. Excellent. So here's how do we convert this thing? We've gotten some progress. How do we convert this into a regular expression? In our 1 minute, we'll just do examples until we run out of time. All right? We're out of time? All right. Then that's how far we've gotten. So you now know everything you need to know in order to do the assignment. You can start. We are now caught up. Actually, if anything, yeah. What? Yes? Let me just